Okay then. So we have studied relations, now we have started functions. Okay. Is it okay if you continue with functions? Better, right? So just now we started definition of functions, isn't it? Let us see once again. What is the definition of function? We know relation is a subset of Cartesian product, right? Cartesian product. A cross B. A into B. Right? The relation is a subset of Cartesian product, isn't it? What is the function? Function is also a subset of Cartesian product. But it will have some specific rules, some specific properties, which will separate it from relation. Which will separate it from being a relation. That is why it is named differently. It is a function. You all must have studied function when you studied limits and derivatives in your PUC 1, Aryan and Janish. Right? You must have studied function of x, isn't it? Now let us see what does this function actually mean. Let us take any two sets. A and B, isn't it? Just now we discussed A and B. Okay? And suppose if we consider A cross B. So we are considering A as the first set and B is the second set, isn't it? Function will also be a subset of this A cross B. Okay? So function will also be some set which will have elements of this form ordered pair. Elements of this form ordered pair, since it is a subset of A cross B. Isn't it? Now, what is the property of this function? Let us see. First of all, if you take any element in the set A, suppose I consider A, B, C and D, small a, b, c, d for A. B may have elements like P, Q, R and S. Yes or no? Yes. Elements. It can be anything. Collection of objects. Set. Right? A and B are sets. So, a function we usually denote it by small f, isn't it? We will denote it f colon A arrow B. F colon A arrow B. What does it actually mean? Function is such that A to B. Function goes from A to B. F colon A arrow B. Isn't it? This is how we denote a function. This F is a function. So basically we are trying to write a function from the set A to the set B. Right? Okay, Jagdish? Yes. Now, when will this become a function? How will it not be a relation? Let us see. In relation, we have something looking like maybe this element is associated with this, right? Association was something like this. Maybe this here, this here, this here, isn't it? Yes. But in function, it won't be that way. It won't be that way. In relation, in your relation, it might have looked something like this. A was associated with maybe 3 of them or all 4 of them. But in function, this will not happen. What will happen? Let us see. First of all, as I just said, what is this set called? The first set is called? The first set, your F. F is such that A to B, isn't it? So the first set is called domain. And the second set is called codomain. If you want, you can take down running notes, okay? First set is called domain. Second set is called codomain. So what makes this F a function from A to B? Usually we say relation is denoted by capital R, isn't it? Relation is denoted by capital R. Usually we say relation is R between A and B. But here we use the preposition between A and B. In function we will say function is F from A to B. From A to B. Okay? Here A is the first set, we call it domain. B is the second set, we call it codomain. What is the property that will make this function F a function? Okay? First property, each and every element of set A, must be associated with only one element from B. That is, you cannot have something looking like this. You can only have something looking like this. Each and every element. You cannot leave out any element from the domain. Okay? In domain, every element is included. Okay? Every element is included. It can look like this, but it will be associated with only one from the set B, not more than one. Maybe it can look like this, it can look like this, it can look like this. See, each and every element is included from A. Okay, so if this is the case, I can see that A is associated with P, isn't it? The element A is associated with the element P. So, for that we will write f of A equal to P. What will we write? F of A equal to P. Here, A is related to P, f of A equal to P. Okay? And after writing this, what are they called? P will be called the image of F. What do we call P? P is the image of A. Okay? Javier, Aryan?
Yes.
P is the image of A. And we say A is the pre-image of P. Okay? A is the pre-image, pre-image of P. Isn't it? This is the basic definition of function. We must have studied in PUC 1. Yes or no? So, just a moment. What's today's date? 13, isn't it?
Yes, sir.
So, what did I say? Your f of A we can write as P. Okay? And so this P is called the image of A. P is called the image. And A is called the pre-image. A is called the pre-image of P. Here. Now, in domain, every element you can see has an image. In domain, number 1 point, every element has an image. And not just image, every element has what? A unique image. Yes or no? Every element has a unique image. Every element has a unique image, isn't it? Sumant? Every element has a unique image in your code.
They don't have unique image, no, sir.
Sorry?
Because P is image for A and P is image also for C, no, sir.
But A has how many images?
One guy.
A has only one image, that is P. But P can have more than one pre-image.
Sorry.
P is related to A and C both. Fine. How many images can you find for A? For A, what is the image? P. Is there any other image for A?
So, A, B, C, D, it can be all image for P, like if we can do.
Understood? All of A, B, C, D can have the image P. But they can have only one image. A has how many images? Only one. P is the unique image of A. And remember, each and every element of A must be included. Each and every element of A must have a unique image in your code. This is the first point. And the second point is what? First point is every element is included, has a unique image in B. Right. Every element, we have said. Second point is the second point to be said. Unique image. First point is every element must be included. Second point is it has unique image. Okay? So you don't need to write it number like that. So every element has a unique image in B. In codomain, what is codomain? Codomain is this set, isn't it? Or set B. Here, first point.
We can have more than one.
Every element, see, every element may not be included. Yes or no? Every element may not be included. So every element may not have a pre-image, isn't it? First point, every element may not have a pre-image. Understood? Every element may not have a pre-image. Yes or no? Here f of A is P, f of B is S, right? F of C is also we can write P, and f of D is Q. Correct? Every element may not have a pre-image. And every element may not have a unique pre-image. Every element may not have a unique pre-image, isn't it? There is a property of codomain. Clear? Every element may not have a unique pre-image. We can see clearly that the element P in your codomain set B, the element small p in your codomain set capital B, it has more than one pre-image A and C, both of them, isn't it? Okay. So by the function of f, we can see that this is what we call a function. Every element, first point, from the domain set should be included, and its image will be unique. And every element of B in the codomain set may not be included, isn't it? And whatever element is included, its pre-image may not be unique. Right? Clear? Clear? This is what makes f a function. For example, if you see something like this, is it a function? No, because B has how many images? 2 images, isn't it? So, it will not be a function. Now, we can see that from the codomain set, which elements have images? P, Q and S, isn't it? P, Q and S. R is not included in the function. Yes, R is not pre-image. So this set is called the range set of F. This set is called the range of F. Okay? And remember, this range of F is always a subset of codomain. Range is always a subset of codomain. Is a subset of codomain. Okay? Not proper subset, but simply a subset, because it can be equal to codomain. I said every element may not have a pre-image. May not have a pre-image. It may have a pre-image. Okay? So range of F is a subset of codomain. These are the basic definitions related to functions. Okay? Clear to this? It is a subset of codomain, isn't it? What is the codomain here? PQRS, 4 elements. Anybody has any doubt up to this? Any question to ask? Javir and Aryan came just now. Any question to ask regarding functions? Tell me.
PQRS is codomain.
Yeah, the entire set is called codomain. The entire second set is called codomain, but range is basically the set of all images. Range of a function F. Range is basically of a function. Why range is of a function? Because the images which you have generated, here, this is due to the nature of function F. This is due to the nature of function. This function F may look something like, I can take f of x equal to say x square, or something, anything, x cube, or x square minus 5, anything, isn't it? So the nature of this function F will determine what your images will be. And this set PQS is the set of all images, isn't it? From the set of codomain. So that set of all images is called range. Range of a function is defined as the set of all images mapped by that function. And also the name function, you can call it a function. What are the other names for it? Function is also called what? The other names. Like your parents call you by some other endearing names, isn't it, at home? So you can also call function by some other name. Anybody remembers? Anybody? I think you must have got it in PUC 1. Huh? No. A function is also called a mapping or a transformation. Remember that? What do you call functions? A mapping or transformation. You can call function. Which color? Blue. Function. You can call f a function or mapping. These are the two most common words. Or transformation. Okay. Basically, you are transforming, isn't it? The function is also called a mapping or a transformation. So here f is a mapping. It maps. F maps A into B. F maps in this relation, in this function, the one we have done, this association. It is not fx equal to x squared. This is just an example, isn't it? This function, we have seen that f maps, maps, maps A into B. Clear? Basic definition of function clear? Anybody, any questions, any doubt? Sujan? Punit? No. Divya, Supriya, Jaivir, Sumant, anyone? Any doubt? No. Clear up to this? Written down your running notes. Can I erase it? Okay. Next, let us look at some special types of functions. Shall we? Suppose, okay, before that, just we talked about function going from one set to another, isn't it? Now, suppose we have the set A, isn't it? So we can also have a function going from the set A to itself. Okay? Relation can be on a set itself, isn't it? Javid? Relation can be on the set itself, A cross A. Similarly, function can be from A to A only. Okay? Function can be from A to A only. Clear? Okay. Now, suppose we have function. We have function. Let us see various types of functions. We have function going from A to B. Okay? These are function f. So, f is a function which will be defined as going from A to B such that f of x equal to y. Right? And this will be denoted by set of all ordered pairs x comma y such that x is from A, x belongs to A, y is from B, y belongs to B, and f of x equal to y. So the collection of all such ordered pairs, this is the collection of, this is a function, isn't it? And it is again a what? Subset of A cross B, isn't it? Because this is the collection of ordered pairs. And we know the collection of all possible ordered pairs between two sets is actually the Cartesian product, isn't it? It's actually the Cartesian product. So this will of course be a subset of A cross B. Okay? Yes or no? Basically, a function is a collection of ordered pairs, right? X comma y, such that again there should be a rule. There should be a rule. This rule can be anything. This rule can be anything. Say, this rule is actually given by y equal to fx, isn't it? Now this rule, it can be anything. It can be anything. It can be, say, y equal to x square, y equal to x cube, or x plus 1, x plus 2, anything. Or maybe y equal to x. Okay? It can be anything. So this set collection of all such ordered pairs x and y. This is of course collection of ordered pairs, any collection. So it is a subset of A cross B, the Cartesian product, because Cartesian product is the collection of any possible ordered pair from A and B, isn't it? Understood? Function is a how it is a subset of A cross B. Okay. You see your books. Okay. So now we'll see types of functions. You see various types of functions. Let us see. Okay. Let us see types of functions. Suppose we have A and B, a function we are defining from A to B. Okay, function f from A to B. Now, suppose A is the set of elements 1, 2, 3, 4, 5. B is the set of elements 5, 6, 7, 8, 9. Say up to 9. 5, 6, 7, 8, 9. Okay. Or maybe I'll reduce one more. B is a set of elements, say 5, 6, 7, and 8. Okay. Now, this set is called domain, isn't it?
Yes.
And B is called codomain. Now, let us see. First type of function, there can be various types of functions, isn't it? You can have a function looking like this. You can have a function looking like this. Right. Here you can see the elements 5 and 8 of the codomain have multiple pre-images, isn't it? We are basically mapping multiple elements from A to on one element of B to any one element of B. Like we have 1 and 2 mapping to 5, 4 and 5 mapping to 8, isn't it? Like that. So these type of functions are called what functions? Many to one. Many to one. So these type of functions are called many to one or many one function. You can either say many to one function or many one function, isn't it? These type of functions are called many to one or many one functions. Okay?
So what is the meaning of one function?
Coming to that, that is what I am saying. Focus on this first. You will say first get the class. Okay, then go home and read the notes. You will see most of them as completed. Whatever I will not cover, ask me in the next class, sir, you did not cover this, then I say. Okay. So we can see here, Jayvir on the board. Many goes to one, isn't it? Just see the nature. If you see the nature, you can just say the name just like that, isn't it? This is just lazy naming, right? This is just lazy naming. Many goes to one, isn't it? Many goes to one. So such functions are called many to one function. Okay? Or many to one mapping or transformation. The most common are functions and mapping. Okay? Function or mapping. So either many to one function or many one function. Okay? Now, we can have a function looking like this. A and B, we can have a function now looking like this. Say 1, 2, 3, 4, 5, 6, 7, 8, say 9 here. Okay. Now, obviously, in a function, all of them must be included, isn't it? All the elements of domain set must be included. All the elements of codomain may not be included. Like 7 is not included in the function. 7 might not have a pre-image. So in many-to-one, the basic definition of many-to-one is that at least one element from the codomain set must have more than one pre-image. At least one element from the codomain set must have more than one pre-image in the domain set. Then the function is called a many-to-one or many-1 function. Yeah. Now, the next we can have a function looking like, say, this. It can look like this. Now see, can you find any element from codomain set which has more than one pre-image? Javier, can you find any element from codomain set which has more than one pre-image? Such functions are called 1-1 or 1-to-1. Such functions are called what? 1-1. See, 1 goes to 1, isn't it? One element goes to one element, isn't it? One element will go to only one element. Okay. So what is a 1-1 function? 1-1 or 1-to-1. Okay. You can call it anything, 1-to-1 or 1-1. So what is a 1-to-1 function or 1-1 function? It is a function in which, you can write on running note definition, it is a function in which an element from the codomain set will have a unique pre-image in the domain set, isn't it? Any element in the codomain set B, if it is included in the function, it may not be included, like 8 is not included. Fine, totally fine by definition of function. But if it is included, it can only have a unique pre-image in the domain set. This is called a 1-1 1-to-1 function. See? 1 goes to 1. This has only one pre-image. Only one pre-image, only one. Very simple. 1-to-1, 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 isn't it? 1-to-1. That's it. Many-to-1 not going, isn't it? Here we have many going to 1, isn't it? In many-to-1, you can even have something looking like this. Here you have an element. Here is an element. Here is an element. Okay. Here you have elements. A many-to-1 function may look something like this also. All the elements may map to only one element. That is also many-to-1. Looking at that corner representation, there is also a many-to-1 or many-1 function. Okay. But in 1-to-1, any element of the codomain, if the definition of 1-1 function is that if an image of an element, if a pre-image of an element of codomain exists, then that pre-image will be unique. If a pre-image of an element in the codomain set exists, then that pre-image will be unique in the domain set, isn't it? Here, just look at the nature, 1-1, 1-to-1, isn't it? Only one element goes to one element. It is a 1-1, 1-to-1 function. Clear? Is it clear? Now 1-1 function has another name. You can call it 1-to-1, 1-1 or injective. Or injective function. Who here does not like injections? Does anyone like injections? You like injections? Does anyone hate injections? Many people don't like injections, isn't it? What do you mean by injection? Injection, if somebody gives an injection by medical, ethics, that one injection that you have been given, that should immediately be destroyed, isn't it? You cannot give that injection to someone else. Can you give it? No, by medical ethics. Only one you can have. That injection can have only one recipient. Right? Not more than one. When everybody took their COVID booster doses or COVID dose, at least one dose you have taken in for COVID. Right. So when you went to take your dose, after giving you the injection, they destroyed the injection, isn't it? You see them destroying that in front of you? Yes. Only one recipient of the injection, isn't it? That is why only one recipient. Okay, that is why it's called injective. You can remember by that. Injection, injective. So, hormone function or injective function. Clear? Anyone? Any doubt? Any question for injective? No? Okay, very good. Can I erase it? Can I erase the board, everyone? Okay. Next, let us see another type of function. So this many to one and one, isn't it? These functions are based on mostly looking at the domain. Like domain. Are you going home or something? So this was one to one and many to one, right? Now we will see this one to one and many to one. Mostly like many one means every element of the domain set is going to a only one element of codomain set, or every element of codomain set, any element of codomain set, if it has a pre-image, that pre-image is unique in the domain set. That is one to one, isn't it? Or injective. Now, we will see two other types of functions. Let us see. This is your domain, this is your say codomain, isn't it? Domain and codomain. Clear? Javier, see? Look at the board. Domain and codomain. Now, diagrams are easier to understand, isn't it? Representation is always easier to understand. Let's follow a little COVID protocol, a little space between them. So, A to B. We are taking again the function going from A to B. Okay? So, in this, suppose the elements of A are 1, 2, 3, 4 again. Okay? Elements of B are 5, 6, 7, 8. Maybe say 1, 2, 3, 4, 5. Okay? Now, let us see. If you have, look at this. Look at, let's say, this. In the codomain set, we'll only look at codomain set. Okay? We'll only look at codomain set. In the codomain set, are all the elements included? Javed? Sumant? In the codomain set, do all the elements have a pre-image? Do all the elements of codomain set have a pre-image? This is the function, right? Is this function? Does it satisfy the definition of function? Sujan, does it satisfy the definition of being a function? It satisfies, right? All the elements of domain have a unique image, isn't it? All of them are included, isn't it? Satisfies the definition, basic definition. Now, in codomain set, are all the elements included? Do all the elements have a pre-image? What happened? Why are you giving blank looks? Are all the elements included in codomain? No. Do all of them have pre-image? No. Well, such type of functions are called, only look at codomain. Such type of functions are called what function? Into functions. What function? Into function.
Is it like many to one?
Sorry?
Is it just like many to one?
It is many to one, but we are concerned with only the codomain. It can be many to one or one to one also. Let me give another example of into function here. This is many to one into, isn't it? Such type of functions in codomain, these are called into functions. But you also said many to one, yes, it is looking many to one, so I'll call it many one into function. Many to one or many one into function. All okay, Divya?
Yes.
Okay. So
when should we call it?
just now I told you the definition. You are just looking at many columns, isn't it? The function, look at this function again. Now we will be looking only at the codomain. Forget your domain. First of all, tell me, does this example satisfy the properties of function? Yes. Is it looking like a function, Divya? It is looking like a function? Is this
Yes, sir.
looking like a function?
Yes.
This is looking like a function? Now, only look at the codomain set. Only codomain. In the codomain set, are all the elements included? Are all the elements included? No. In codomain set, do all the elements have a pre-image? No, because 7 does not have a pre-image. Do all the elements in codomain have a pre-image? No. Then such functions are called into functions. What are into functions? Into functions are functions in which Sumant is just looking at me. Sumant, if I take your notebook, I'm sure you've written nothing. Isn't it? You've written. Can I see? No, I can't see that. Don't worry, Sumant. My eyes are everywhere. I can see each and every one of you, what you're doing, what you're not. Okay. Since I am teaching here, I'm sometimes standing also. My view is fine, isn't it? So that is why I told you, Sumant, come at the front bench. What? Your hand is painting, like you don't want to write or something. Ink is less in your pen. Don't worry, I have 3 pens. I can give you which color you prefer. I have blue, black, red for checking. You can have any pen you want. You can make it as colorful as you want. You can use pencil also. Anybody has pencil? Somebody can give me pencils. There, she has pencils. Your wish, mode of writing. Okay? That will give you a grey color, isn't it? So, what is an into function? Only look at the codomain set. Okay, Divya? You missed nothing, don't worry. Because of Aryan, because when he zoned out, only look at many one. Good, you should zone out, but right now just focus. Okay, in mathematics, zoning out is a nice thing. Mathematicians should be thinkers. Now, when we are talking about into function, right now, we'll be talking about 2 more types of functions. We talked many one and one, right? Javir? Divya?
Yes, sir.
Divya? So, now we will talk about 2 other types of functions in which we will look at only the codomain set. Just look at only codomain. That is why I did not even write domain there. Only look at codomain. In codomain, are all the elements included? No. Do all the elements have a pre-image? That means do all the elements in pre-image? No. Isn't it correct? 7 does not have a pre-image. It can be more than that. It may have been 8 was not included. It could have happened, right? Then, such type of functions are called what functions? Into functions. Okay? Again, it can look something like, maybe say, this is this. Maybe say this is 7, 8, 9, 10. It can look something like this. Say 6, 7, 8, 9, 10. It can look something like this. Now see, what is this? Is this an into function? Is this an into function? My question mark.
Yes, sir.
Is it an into function?
Yes, sir.
Why is it an into function? Because the 6, this element 6, does not have a pre-image. It satisfies the definition of being a function, isn't it? Each and every element of the domain set has an image, and all those images are unique. See? Now see, if you can look very carefully, these are 2 different types of into functions, isn't it? Why are the 2 different types? Because of the 2 types we discussed a little while ago. One was many to one was one to one. So, in types of functions, the complete name will look like this. First you will write whether it is many to one or one to one. Here it is many to one. So for this I will write many to one or many-1, many one. So this function will be, the complete name will be many one into function. What is this complete name?
Many one into function.
Many one into function. Understood? This is the complete name. Into we'll write later. And since many one has one as its complement, into also has something coming. Just wait a minute. So it is called many one into, and what is this? Is 1 just now straight. So this we'll call it 1 into function. Is this clear? This is the complete name of the function. You have to look at two things. First thing, whether it is many one or 1. Second thing, whether it is into or after this, whether it is onto. Okay? Whether it is into or whether it is onto. So let us look at that. Can I erase the board? Anyone? Any objection? Any doubts to us? No. Can I erase the board? Quickly note it down. If you want, quickly note it down. Can I erase the board? Yes. Everyone, Supriya, can I erase the board? Okay, quickly. Javier, is it clear? Any doubt? Understood? We studied into, right? Now we'll look what if it is not into. Obviously, what if it is not into? Onto. Okay, what if it is not into? Then it will be onto. Into, onto. Nice name, isn't it? I or O. Into, onto. Done? Can I erase? Yes. Can I erase? Okay. Only this much. Let us see. Into, onto. Let us look at this. Again, for onto also, we will see only the codomain. Now see, in your codomain, this is a function. First one, is this a function?
Yes, sir.
Satisfies the properties of function, Suman? Is it? Bigger here? Only one letter difference, no, sometimes the tongue slips. Okay, so does it satisfy being a function?
Yes.
It is a function. Javed?
Yes.
It is a function. Now, in this, again, look at only codomain. Are all the elements of codomain included?
Yes.
Do all of them have a pre-image?
Yes.
All the elements of codomain has a pre-image?
Yes.
In it? All of them? So, such type of functions are called what function? Onto function. And remember, don't look at many one. If your function is simply onto by looking at codomain, you can also call it surjective. We studied injective. Injective was 1, isn't it? Injective was 1. Let me write it here. These special names. Only these two have special names. Why? We'll see this. 1 has a special name. It is called injective. Okay. And onto has a special name. What is this called? Surjective. Okay. Surjective. Onto is called surjective. Clear? Injective, surjective. If it is simply onto, we don't care about whether it is many to one, 1 to 1, we don't care about that. If it is simply onto, that means surjective. Which one? You two are sitting in a straight line. Okay. That time also when I called you, we were looking. Okay. So if it is simply onto, surjective. You don't need to look at many one or 1. Here. Now, let us see this. This is onto, isn't it? But what is the complete name of this function? We have to include many one and 1 also. Then we will get the complete name, isn't it? The complete name of a function will comprise of whether it is two categories. First category, many one or one one. Second category, into or one. Here, there are two categories. One is many one, one one. Another is into or one one. Combining these two and writing them together, then you will write the complete name of the function. First part will be many one or one one. Second part will be into or one one. Yeah. So this is what? Many one or one one? Many one. Many one or many to one? Anything. Many one onto function or many to one onto function. Clear? Now let us look at this. Now look at this. This function. Is it into or onto? This function, is it into or onto?
It's onto.
Onto, because each and every element of codomain has a pre-image, isn't it? So this is also onto. This is also surjective. Now tell me whether it is many to one or one to one. One to one or one one, isn't it? This is the complete name. One one onto, isn't it? One one onto. One one. Yeah, I'm coming to that. I'm coming to that. Very good. I'm coming to that. Good. Make your brain wander that way. Yeah.
How are we gonna call it like that?
Exactly. I'm coming to that. I'm coming to that. This is a one one onto function, isn't it? So this function, why is it onto? Because each and every element of the codomain has a pre-image. And see here, for onto functions, what did we see? Range equal to what? What is the range set? It is the subset of codomain. And range set is the set of all images. Here which are the images? All the elements. So range will be equal to codomain, isn't it? Understood? Will range be equal to codomain? Won't range be equal to codomain? See? Yes or no? Will range be equal to codomain? Punit? Aryan? Sujan? Sudhakar? Yeah? What is the meaning of range? We just defined range, right? Range is the set of all images. Range is the set of all images. Here you can see in onto that each and every element of codomain is an image, right? It is included. So what is the set of images? The entire codomain set. So doesn't the range become the codomain itself? The range becomes the entire codomain itself. Anything is left from the codomain? No. So in an onto function or a surjective function, range is equal to codomain. Here, when is range equal to codomain, the function becomes surjective or onto. Okay, clear? And the complete naming of a function is one one onto or many one onto. First you write whether it is many one or one one, then into or onto. Clear? Now, one one has a special name injective. Onto has a special name surjective. Now, if it is one one onto, like we have seen here, it is one one onto. What do we call it? It is injective as well as surjective. It is injective as well as surjective. So, very nice and important. You can write it down. Remember this, the most special type of function you can find. If a function is injective as well as surjective, if a function is injective, in bracket you write 1 1. If a function is, Punit is just thinking, he's writing in his mind. Okay, fine, you can write in your mind library. Anyone watches Sherlock Holmes? Anyone has watched Sherlock Holmes? No. Sherlock Holmes. Benedict Cumberbatch. Mind library. You don't know what season 4, season 3? Sherlock Holmes has his mind library, isn't it? He has a library in his own mind. Okay. So the way Punit was reacting, it was as if he's writing this in his mind library. Okay, write it down quickly. If a function is surjective, if a function is injective, the function is injective in bracket 1 1, as well as surjective in bracket onto, then that function is called A 1 1 1 2 function. Or I'm coming, yeah. Then the function is called a 1 1 1 2 function or a bijective function. Then that function is called a 1 1 function or a bijective function. So remember this. This is the most interesting type of function, which is bijective function. In bijective function, you can see that it is 1 1 and 1 both. Then it is called a bijective function. Okay, Jaivel? It is a bijective function. Punit, clear? Aryan? So, Punit, if a function is both 1 1 and 1 2, you heard about 1 1 2, right? The function is both 1 1 and 1 2, it's called bijective function. In onto function, we can see that range is equal to 4 domain. Range is a set of all images. If a function is 1 1 as well as 1 2, 1 1 means injective, 1 2 means surjective. If a function is injective as well as surjective, we call it a bijective. Objective? Bijective. Bijective function. Very interesting. Look at the bijective function nature. Every element of domain is included. Every element of codomain is included. Isn't it? It is 1 to 1, not many to 1. It is 1 1, not many to 1. It is simply 1 1, not many to 1. Every element of domain is included, isn't it? Every element of codomain is also included.
So if on to not into. So if on to not into.
Again, Aryan is not talking. We are talking about bijective now, isn't it?
Yes, sir.
Yeah, bijective means onto. Yeah. Bijective means onto. Your into does not have any particular name. Into does not have any particular name. Naming are there, special naming are there for only these three types of functions. One is if it is 1 1 injective, if it is onto surjective. If it is both injective and surjective, both 1 1 and 1 2, it is called a bijective. Understood? What is the meaning of bijective function? Remember, bijective is a very special case of function. One of the most important types. Remember that. So if it is 1 1 or 1 2, both it is 1 1 and 1 2, both it is bijective. And how we name a function? The complete naming is first you write many 1 or 1 1, then you write whether it is into or not. Okay? So 1 1 on 2 or bijective. Special name bijective. Clear? Anyone wants to ask any question? Any doubt? Plus I said if it is on 2, we can clearly see range means set of all the images, isn't it? Which is actually equal to the entire codomain set. Range is equal to the entire codomain set. Clear? Suman, I'll ask you this tomorrow. If you can't answer, then I will tell you why did you write. Even if you write, you won't go home and study like Sudhakar. You have to do homework. Very good. Okay. Understood? Anyone? Any question from function? Anything? Any doubt? Any query? Any thoughts? Any thoughts? Any imaginary scenario? Anything? Anything? You can ask. All our definitions are done from function like this. Now we'll only have to look at the examples. Yes, only examples. Then we'll look at the next topic on composition of functions and derivative of functions. Okay. What else is left? Binary operations. I hope that's done. So, understood bijective function? 1 1 and 1 2. Good? Now, so this timer just put a timer for 6 o'clock, isn't it? If this starts now?
Yes.
Just a quick reminder. If you're given two cells, a set, but what is the order of a set? The number of elements in the set? The order of a set is number of elements in the set. If a given set, if remind us tomorrow we'll do examples based on function, okay? Get your books, look through the function, solve the examples given in your book, okay? Study those examples. Tomorrow we'll discuss those. Now, before leaving, just a thought. In a given set, suppose a set, what is the number of elements called? Order of the set. Now, just see, what is the bijective function? It should be 1, 1 and 1, 2. Which means, each and every element of domain is included, each and every element of codomain is included. 1-to-1 connection, it should be on-to, isn't it? Bijective. If both the sets A and B are finite means finite number of elements. Then if there exists a bijective function, suppose there exists a bijective function between those two finite sets, then what can you say about the number of elements of those sets? Anything?
Number of range is equal to the number of columns.
That is for on to, not number of range. Like range is equal to codon. Range means what? Range is collection of the set of all images. If it is onto all the elements of codomain are images, they are all included. So range becomes equal to codomain. Here we written them. But my question is that if your domain and codomain sets, the two sets I am taking are finite sets. Because if it's an infinite set, for example, set of natural numbers is infinite, set of real numbers infinite, set of rational numbers infinite, set of integers infinite, set of prime numbers infinite, set of odd numbers, even numbers infinite, set of factors of 6 finite, set of factors of 6 1, 2, 3 and 6 finite, set of factors of any number finite, set of factors of any finite number is finite, set of factors of 100 will be finite, right? So if my two sets I am taking are finite and I am saying that suppose there exists a bijective function between those two sets, then can you tell me anything regarding the number of elements of those two sets?
So will it be the number of elements in set A? Will it be the number of elements in set A because it's the domain in set A?
Sorry, tell me again.
Will it be like the number of elements in set A?
Can you tell me anything regarding the number of elements in both the sets A and B? Anything? Anything? Number of elements of domain will be equal to number of elements of codomain. Isn't it? If one of them becomes, they are finite. Just imagine here, A is having just one extra element than B. What will happen? Will it remain 1 to 1? Because you have to include that element, isn't it? Just imagine, take this example only. Suppose A has one extra element, say 5. You have to now include this 5. It has to map to some element. All of them are busy. Something will come here, isn't it? Something. Or this. Does it remain 1 to 1? Does it remain bijective? No. Similarly, if B has an extra element, say just extra element, anything. Now, you cannot include it, isn't it? Because no other element is left in A. No other element is left in A. Each and every element in A has got its image, isn't it? Can you include any element from the domain set? No, right? So, is it an onto function? It becomes into. It is 1, 1, injective, 1, 1. But is it an onto? So has it remained a bijective? It is no longer a bijective. But this is your bijective. So if you are taking two finite sets and I say that there exists a bijective function between those two finite sets, then what can you say? Number of elements in both the sets, domain and codomain, should be equal. Number of elements should be the same. Okay? Say 4 elements, 4 elements. Understood? Clear? Yes, sir.